These are always great fun, finding out where polar functions intersect. So first, make sure the mode is polar. Y equals sine of 2 theta. Take a look at the graph. Sine, the biggest it gets is 1, so the x's and y's look right. And then it's a 4-petaled rose. And then when does that intersect with tangent? So it seems that there's probably five intersection points. These out here on the edges, and then they both look to be going through the origin. So it looks like we've got 5 intersection points. Let's see. So when are these two functions equal to each other? So when does sine of 2 theta equal tangent of theta? And for sine of 2 theta, there's only one identity. It's 2 sine of theta cosine of theta. And since the left-hand side is now in terms of sines and cosines, we should do the same on the right-hand side. Tangent is equal to sine divided by cosine. And then multiply both sides so that we can clear the fraction. There's going to be a cosine multiplied with cosine. So cosine squared. And then since there's a sine over here and over here, I should collect those on one side, let's say the left-hand side. So subtract cosine, subtract this sine from both sides. And then factor it out. So sine gets factored out. There's going to be 2 cosine squared and then minus a 1. And then there's even an identity for that. That's cosine of 2 theta. So one of my mantras is that the angle should be the same, either all theta or all 2 theta. One exception is when it's already factored and set equal to 0. It doesn't matter because the factors are going to be taken apart anyway, and you set each one equal to 0 individually. And so this one would be when does sine equal 0, that would be at 0 and pi. And at 2 pi. And then cosine of 2 theta. So when does cosine equal 0? Well, that requires a little bit bigger of a picture. So there's the cosine graph. And in the middle is pi. Over here is 2 pi. And where is it equal to 0? Well, that would be here, which is pi over 2. And then over here, which is 3 pi over 2. But then that's what 2 theta equals. And now I should go back to the graph and see if these look right. So trace and 0, well, that's the origin where they're crossing, so 0 seems right. And trace and put pi, that's when they go through the origin again. And 2 pi is probably the origin again. Oh. Hey, if this ever happens to you, this is what's going on. So when I typed in the window from 0 to 2 pi, that is the exact number 2 pi. When I hit enter, it then puts a decimal approximation, which is just slightly smaller than 2 pi. So then when I tell it trace, and I want you to plug in a 2 pi, it's using the exact value 2 pi, which is now just slightly bigger than the window, and it says that's outside of the window. So I say go to, what are you complaining about? The 2 pi. Well, 2 pi is approximately 6.28, so if I type in 6.28, it'll then be the origin. All right, we need to check these over here. This one's going to be pi over 4, so trace pi divided by 4, that's that intersection point. This one would be, when you divide by 2, 3 pi over 4. So we've got these two, but we didn't get those two over here. So from this one, we need to get 2 more solutions. So add 2 pi to each of these. Well, 2 pi over 2 pi, if I want to change it to be over 2, is going to be 4 pi over 2, plus this one is 5 pi over 2. And then when I divide by 4, let me see if that works. 5 pi divided by 4. Oh, that's this one down here in the left corner. I don't know if you can see it, but it's flashing. And then another one, well, if you look now, there's a pattern. They're just odd numbers. 1, 3, 5, next would be 7. 7 pi over 2. So the final one should be 7 pi divided by 4. It's that one. So I just need to then write down theta equals 0 and pi, and then pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And then I don't really have to put the 2 pi because that's the same as the 0.